This video we're going to talk about exercise 4.1 question 1 and 2. So first of all, they're asking about how to find an intersection between two straight lines. So you can see from here there's L1 and L2, and this point is going to be our intersections. So if you want to find out this intersection, which means that they have the same, so they have the same x and y coordinates. So which means that we can set these two equations to be the same. So now we have L1, which is x minus y plus 1 equal to 0, and L2, which is x plus y minus 5 equal to 0. We can first change it becomes to the y equal to mx plus c format, so that we have y is equal to x plus 1. We just move this negative y to the right hand side, so it becomes y equal to x plus y. And for the second one, you keep the y here, you move the x to the right becomes minus, you move the negative 5 to the right becomes plus. So now I have y is equal to negative x plus 5. So now as I said, they have the same y, isn't it? So this is the y of L1, this is the y of L2, because they are the same. So you can set these two equations to be the same. So now we can say x plus 1 is equal to negative x plus 5. Now we solve for this equation. I want to move the x to be together, so I move the minus x to be here, becomes plus. So x plus x is equal to 5 minus 1. I move this positive 1 to be here, becomes minus. So now x plus x gives me 2x equal to 4, so that x is equal to 2. So after you find out the value of x, you need to substitute back to either of the equation to get the value of y. So now I have the y is equal to 2 plus 1. I just substitute the x to be 2, or you can actually substitute this x be 2 as well. So now I can say the y is equal to 3. So the intersection is just 2, 3. Okay, so similarly for question 2. So I can do question 2 here. So for question 2, we still have these two lines. That is L1, which is x plus 2y plus 15 equal to 0. And we also have L2, that is x equal to 3y. So which means that at this intersection point, they actually have the same x and y, isn't it? So same x and y. So that we can substitute the x into the equation. Because they have the same x and same y, so I can replace the x by this x. It's actually the same x, but this x is actually equal to 3y, so that I can replace this x by this 3y. It's actually solving the simultaneous equations in two unknown. Okay, so now I can just substitute L2 into L1, so that I replace this x by 3y. So now I have 3y plus 2y plus 15 equal to 0. These two combined give you 5y equal to negative 15, so that y is equal to negative 3. After I get the value of y, I just substitute back to our equation, either one, and then I can get the value of x. So now I have x is equal to 3 times y, that is negative 3, so that x is equal to negative 9. So that the intersection is equal to negative 9, negative 3. Okay, so that's how you find the coordinates of the intersections, or you can actually using program 1. Do you still remember it? So we can actually using like this. For example, I can change it becomes x plus 2y equal to negative 15, x minus 3y equal to 0. So that is, you move all of the variables to the left. So x and y on the left hand side, and on the right hand side of the equal sign, that is the constant, only the number. So you change all of the straight line equations into this format, then you can just use your program 1, and then you press 1, 2, negative 15, and then 1, negative 3, 0. And then the next value is going to be x, the next value is going to be y. It's much more quicker because you're senior form now. You don't need to give me all of these steps. You can just use program 1 to get your answer. Okay?